We're going to look at question 3 of the term 2 control test, and this was the Doppler question. So, the diagram shows a moving source of sound, wave in air, illustrates the Doppler effect. First thing they say is define the Doppler effect. Guys, learning definitions really isn't an option, so I'm going to write this one out because I think there's a little bit of confusion as to what you should have here. So for this one, it is the apparent, very important, apparent change in frequency or pitch, alright, of the sound detected by a listener. Now look carefully, because the sound source and the listener have different velocities relative. I'm about to put two words together there. Have different velocities. There we go. Relative to the medium of propagation. Okay, guys, you gotta learn definitions. You have to. Alright. Then, now they say to you, in which direction is the source moving? To the left or to the right? Now, most of you got this, right? So, you recognize they're getting closer together on the left, further apart on the right. So, yes, it's got to be going to the left. Perfect. Now they say a commuter train traveling at constant speed of 40 meters per second blows its horn as it passes a stationary buoy. The frequency of sound emitted by the horn is 340. So, that's the velocity of my source. That's the frequency of my source. Calculate the wavelength, lambda, of the sound observed by the buoy when the train moves away from him. That means frequency must decrease. Okay, wavelength gets bigger. Take speed of sound in air to be 340 meters per second. You recognize that we're going to use this equation. This was not an issue. Alright. In order to get the wavelength, I need to know the frequency. So I need the frequency of the listener. The listener wasn't moving, so 343 is enough for the listener. The train was moving. The train was moving away from the listener, so my frequency's got to get smaller, which means I've got to add that velocity. And the source is 320. That gives me a frequency that's heard by the listener of 286.58 hertz. Now you made a mistake which I saw far too often. A lot of you recognized I need to use V equals F lambda. But you got confused with what this V is. This is the speed of sound, not the speed of the train. The speed of sound didn't all of a sudden become 40. This is 343. This is 286.58. I want lambda. So lambda becomes 1,2 meters. A lot of you used 40 instead of 343. Silly mistake. You lost 2 marks for that. Okay, so you just need to be careful with that. This V is the speed of sound, not the speed of the source. Okay.